4.8 complex numbers. The prime numbers, the prime answers we had before will now be revealed as we begin working with the complex numbers. I think you'll like this section. It's really easy. It's very easy to work with, and it's an important part. So let's go. All right, so earlier in the year we learned about all the sets of real numbers, and today we're going to learn about the non-real numbers, or complex, or you may even hear them called imaginary. Same thing. Non-real, complex, imaginary all mean the same thing. Real numbers are a smaller subset of complex numbers, so it would be like our solar system that's in the even bigger solar system. Okay, so we have just a small little system compared to what's out there. And that's the way the complex numbers are. Complex numbers include all numbers that are real and non-real. So it's like the big kahuna. Complex numbers can be written in the form a plus bi, where a and b are real numbers. If b is 0, if you plugged in a 0 for b, then the number is going to be real, because all you're going to have is a plus 0 I, 0 anything, it's just 0, so it's just going to be the real number. But if a is 0 and b is not 0, then the number is a pure imaginary number. It'll just be 2i or 3i. That's a pure imaginary number. If it has non-real parts and real parts, then it's just a complex number or an imaginary number. Examples: 2 plus 0i equal 2, which is a real number. But 2 minus 3i is an imaginary or complex number. But if you put 0 plus 4i, you just get 4i. 4i is a pure imaginary. It's nothing but imaginary. There's nothing added to it. All right, so recall when we had the square root of -1. We could not do that because it was an even index, and we couldn't take out negatives out of an even index. That's because the number is complex or imaginary. We will now learn the properties of these imaginary complex numbers. All right, so now I like to write this up on my board, and you'll see it. I'll leave it up there until right before the end of the year when we have SOL test. But the square root of -1, heart math. Can you guess what square root of -1 is? Okay, this equals I. So that sign really says I love math. These imaginary numbers are always denoted with the italic little I. Things you should know about an I. All right, so I is equal to I. Okay, I is equal to I. Or the square root of -1. The square root of -1 means I. Okay, so let me write that next to it so you have that. That's the same thing as I. All right, I squared is -1, because remember, squaring undoes square roots. So I squared is often used. We're going to be using a lot in this section. You need to know that I squared, when you see that, it's automatically, you know that means -1. That's a number you can work with, okay? So I squared is -1, right? Because if you do a square to this, it undoes the square root. Okay, so if this was squared, you take the square root of that. Let me just show you. I squared, taking the square root would just mean that it's going to be -1. Okay, these undo each other, remember. All right, so I to the third power is going to be -I, because if you have I squared times I, that would give you I to the third, right? Well, I squared, we just learned, was -1 times I will give you -I. That's what happens. It's not so important that you know how it works with this. Just know there's a pattern of 4 that you have to know. It repeats. So then I to the fourth power is 1. So let me clear this off real quick. And so what you need to remember is these 4 patterns. Okay, it goes from I to the first power to I to the fourth power. Those patterns repeat, okay, infinitely. So if you know the first 4 powers of I, you'll know them all. However, there's tricks to these. You'll hear me refer to these as the sandwich, okay, because it just goes I, 1, I, 1, negative I, sandwich. There's the bread on the ends and there's the sandwich. So I always call it the I sandwich. I, 1, negatives in the middle sandwich. Okay? If you want to know the pattern. I, 1, negative I sandwich. All right. Now, the rest of those then repeat. So you'll see I to the 5th makes I to the 6th makes the negative 1. I to the 7th make the negative I to the 8th make 1. So it goes over and over and over. Do you see that pattern? Even if you don't, you can use your calculator if you have it set up right. Now let me show you how to do this. Let me pull up my calculator. All right, let me turn it back on. All right, so if you want to use your calculator, and I recommend highly because your calculator will do this stuff for you. It's very, very nice. I wish we would have these in my day when I was in school. But you're going to want to always check your calculator. It is up to you to remember to do this because you know I have other kids in other classes and they have different settings than you do. Make sure every day you come in, you check your calculator. Now, if you use your own, that's fine. But remember, when we do SOL testing, you won't have your calculator. You'll have one of ours. So you need to get in the habit of just every day checking this. So when you come into class, you need to turn on your calculator. You need to go to mode. Okay? See how it's clicking on normal? And that's great. Roll down with using your scroll button. Go down to the line where it says real. Okay? That's real numbers only. I want you to scroll over and look what you have. You have A plus BI. That means the non-real numbers. That's what it needs to be highlighted on every time you come into class. It will never mess up your answers for anything else, but if you don't have it on, you can't do the non-real stuff. So make sure it's highlighted and hit enter, and then go back to your working screen. Okay? So now anytime you put stuff in, prior to when you put in square root of -1, you would get an error message because you couldn't do it before, right? Because we didn't have it on the right thing. Watch as I put it in now. Hit enter. There's your I. Okay? So now, if you don't have it in that mode, you won't be able to get the right answer. So please make sure you do that. Now, watch. If you want to type in any of the I problems, okay, you look down here where it's got the little period button. You see that little yellow I? That's your I button. So you're going to always have to hit second I to do any of your I problems. Now, if we wanted to try I to the 21st power, of course you do I, and then this up button will work for any of the powers. So I hit 21 and hit enter. Now, I want you to notice the answer that you get. Some kind of nasty looking thing. It's really not bad. All right, this is in scientific notation. Okay, -1e to the -13. You're working in chemistry, most of you right now. Okay, and you know that scientific notation is really -1 times 10 to the -13th power. All this right here up until this plus is scientific notation. Okay, that's what you want to just eliminate when you're working with these because your answers have to be I, -1, I, or +1. That's the only choices you've got. However, now see, you see this -1, that's attached to the scientific notation. So all the things attached to the scientific notation, disregard. Okay? This I at the end is your answer. So remember, it's going to be a number, E, and then another number that might even have a little I with it, okay? But it'll be multiplication, not addition. All that just eliminate, and then your answer is the stuff on the end. So this would just be I, all right? Got all that? Next problem. Now it's really funny. This is one of the easiest things to do. I ended up with more slides on it than some of the harder stuff because I just really wanted to make sure you understood how to use your calculator with all this stuff. It's very, very simple. All right, so when you're adding or subtracting complex numbers, you're going to add like terms. So you're going to add real numbers to real numbers and complex numbers to complex numbers, and then, as we've said several times this year, simplify is the word of the year in Algebra 2. All right, so they give us 6 minus 12i minus 4 plus 3i. Now remember, this minus in between means that goes with everything that's in here. So you really, if you want to, change that to a plus. Let's change color. Change that to a plus and make this negative and make that negative. You have to change all your signs. You're subtracting both things from this. So this is 6 minus 4, and I just put my real numbers together. 6 minus 4 and negative 12i minus 3i. Okay? My reals are together, my complexes are together, and then just simplify. 6 minus 4 is 2, negative 12i and a negative 3i make a negative 15i, and that is done. Okay, that's as far as you can go. All right. Multiplying or dividing complex numbers, you're going to distribute and simplify again, but be careful. If you ever end up with an I squared, you have to substitute in negative 1 because it's not simplified. You know now that I squared is negative 1. That must be put in there. I's, you're going to get all sorts of kind of weird answers, but sometimes there's going to be a plain number. But if you don't plug that in and you leave it at I squared, it's not finished, it's not simplified, and it will be wrong on a test or quiz. All right, so when we're multiplying these, you just distribute this 2 right here to both of the other terms in the other problem. So it's 2 times 4 and 2 times 3i. 2 times 4, 2 times 3i. Then you do the negative 2i, negative 2i to the 4 and negative 2i to the 3i, as I wrote it out. Then you just simplify. 2 times 4 is 8, 2 times 3i is 6i. 2i times 4 is negative 8i, and a negative 2i and a negative 2i times a 3i is going to be a negative 6i squared. Okay, so when you simplify this up, it's going to be 8. 6i minus 8i is going to be a negative 2i minus, because it's a minus in front of the 6, times negative 1. So I had to substitute in negative 1 where there was an I squared. And then you get 14 minus 2i. Okay? So this ends up being a plain old number on the end with just your imaginary in the middle. Okay? So these will end up looking different. Each one can be different. Please don't think they're all going to look like this. Some of them might have 3 terms. Some of them might have one term. Some could have 2. At this point in the game, when you're in Algebra 2, things will be all sorts of different. Okay, there won't be one pattern for everything. All right, so dividing cannot have an I in the denominator. Okay, just like with the radicals, you couldn't have radical in the denominator because I really is a radical. I is the square root of negative 1. So you can't have that in there. So you got to treat it like it's a radical and use conjugates. Conjugates are what we talked about with the radicals. It's just the opposite, okay? So looking at this, a plus bi, the opposite would be a minus bi. These two are opposites of each other, okay? We use those to get rid of those i's. All right, so multiply the denominator and the numerator by the conjugate of the denominator as you did with the radicals. What happens is when you're doing this, when you multiply a times a, you're going to get a squared. And a times bi, negative bi, is going to be negative abi. Then you do the bi times a, which is going to be a positive abi. And then you have bi times a negative bi is going to be a negative bi squared. So you see the middles will cancel out. All right, and then you end up with bi squared. And I squared, the reason why we use the conjugates, they go away because I squared we now know is negative 1. So that really ends up being negative b times a negative 1, which will make plus b. This will end up being a squared plus b. Okay? So that's why it works. All right, so for an example, if we have 2 minus 2i divided by 3 plus I, that just simply means we have to take this down on the bottom, turn it into the conjugate, and multiply the top and the bottom by the conjugate. And I did that down here. So the conjugate of 3 plus I will be 3 minus I. So you notice I multiplied it by 3 minus I divided by 3 minus I. And the reason why we do that is because that really makes 1. So it doesn't change the problem at all. It just manipulates the workaround so that you can use it. That's the whole point of math. All right, so when we do this, when you multiply, you're going to get on the bottom 3 times 3, which is 9, and then 3 times a negative I, which is negative 3i. I times 3, which is a positive 3i, and then I times a negative I, which makes a negative I squared. That is the bottom. So you see how this cancels out. I squared is negative 1. All right, notice it's a minus in front of it already, so you need to keep that in your problem. That turns into a plus 1. That's why 10 is the only thing that's on the bottom, which is what we want. We don't want anything except for plain old numbers on the bottom. Then you multiply the tops, 2 times 3. And if you need to make parentheses around these expressions, you know, so you'll see that you've got to multiply, do that. Most of the time you won't see it with parentheses. You're going to have to just know that these are expressions. All right, so it's 2 times 3, which is going to be, let's use yellow, 2 times 3, which is 6. 2 times a negative I, which is a negative 2i. Whoa, how did I go up there? Let me fix that. Yahoo! That wasn't, y'all could see this little gizmo I have to use. It would be very funny. 2i. All right, so then you do negative 2i times 3, which is negative 6i. And then negative 2i times a negative I. So that's going to be a positive 2i squared. All right, so you know this I squared has to be simplified to negative 1. So this negative 1 times 2 now makes it a negative 2. So it's going to be 6 minus 2. And then negative 2i and negative 6i make a negative 8i. Did I do that right? Weird. Let me double check my math. I could have messed up my little PowerPoint. That would make me mad. All right, so let's do 2, 6, negative 2i. And then this is negative 6. Oh, this should be an 8. Bad. All right, now I got to fix my PowerPoint. Yippee. This should be, an 8. All right, so it should be 4 minus 8i over 10. Now, let me show you what you can do, okay? Any of this stuff with this I stuff, you can put in your calculator. Now watch how I do it, all right? With division especially, you have to at least set it up so you can do the conjugate, okay? you at least have to have times right here, and then 3 minus I. After that, you know, you're good to go, but you must at least do that. It won't do it all for you, okay? So if I bring my calculator back up, and I type in, and I'm going to use parentheses anytime I have an expression, okay? So that's going to be parentheses, ooh, why is it not working? It's not on. Okay. Why is it not on? There you go. All right, parentheses, 2 minus 2 second period, parentheses, okay? And I'm just going to do the top part first. Do the tops and then the bottoms and then clean them up if you need to. Times. Oops, I even wrote that wrong up there. Hold on, let me fix it. My goodness, the brain has lost it. This 3 minus I. Sorry, guys. Trying to talk and walk. I don't think I can do both. All right, so then I'm going to do 3 minus I. That's the conjugate of the bottom. Second I. Okay, so 2 minus 2I times 3 minus I. Hit enter. Okay, so it does the top for you. See, I told you it was supposed to be 8I. All right, there's the top. And then you're going to put in the bottom. Okay, 3 plus I. Please use parentheses. I can't stress how easy your life is, if you will. Whoops, too many parentheses. Delete. How much easier your life will be if you use your parentheses and put things in the calculator like I show you. Even though it takes a few minutes to do, it'll save you a lot of trouble. All right, so you notice this is the bottom. So it's 4 minus 8I divided by 10. Now, if you run into that situation, you can simplify the outside numbers. You know what I mean by that. That 4, the 8, and the 10 can all be divided out by 2. So then this one should really simplify too. Let me show you if I can set it up then. I'm going to put parentheses 4 minus 8I, which is the top, okay, divided by 10. Oops, not 1. Enter. Math, enter, enter. Okay, it does. So you see, it will do this for you, and even if it gives you decimals, you can make those into fractions, but let me show you what that looks like if you write it out, okay? This will be, so we have, I'm going to write it down here, and then I'll clean all this mess up. It'll be 4 minus 8I over 10. Dividing out 2 from each, that'll be 2 minus 4I divided by 5, right? Well, notice what your calculator had. It had 2/5 minus 4/5 I. That's exactly what I've got here. 2/5 minus 4/5 I. Okay? So just know that you can split it up in your calculator and it'll do it for you. Okay? The only thing it won't do is, put a plus minus in front of things. This is really easy to use all this section on your calculator. Right? So square roots of negative numbers or any even index. Remember we said we couldn't do that? Well, now we can. There won't be anything prime anymore. Okay? Square root of a negative x. When we're taking the square roots of negative numbers that are even index, you must take care of that negative in the radical first. That negative right there just simply comes out and makes the I. Okay? That is all it does. You take that and take care of that first before you do anything else. So this simply comes out as I, and you've got rid of that negative, and now it's just I square root of x. And then if you need to simplify from there, you can. The I must come out first, okay? All right, so when you have this problem, notice we had the square root of negative 64 before. We said, no, we can't do that because it's an even index. Now we can. All right, we know that this negative under the radical sign is, and if it's an even index, it's an I, so it comes out. So this will be plus or minus 8I, because we learned that even indexes, it could be a positive or negative that make it a positive number on the inside. So this would be a plus or minus 8I. All right, if we're working with these and we're adding square root of negative 4, we take care of that negative first. So that really becomes 2I, plus or minus 2I, plus, and then we have the square root of negative 9. We take care of that right off before we do anything else. That becomes plus or minus 3I. So then you simplify. That's going to be 2I and 3I. It's 5I plus or minus. All right? When you're multiplying a negative square roots of negative 3, that negative under the radical comes out first. So that would be a negative I square roots of 3. This negative square root of 6, that negative under the radical comes out first. So that'll be I square roots of 6. And then you simplify, okay? Outsides times outsides make a negative I squared. 3 times 6 makes a 18. Okay, so you need to simplify that out. Negative times negative 1, because you must plug in a negative 1 whenever you see I squared. That becomes a positive 1, which essentially goes away. And then you do simplify your 18. That ends up being 3 square roots of 2, which is going to be your final answer. Okay, so you take care of those negatives under the radicals first. They become I. All right. Remember when we factored, we were given a problem like this. X squared plus 25. I threw those at you just to mess with your minds because I was trying to get you to look for those patterns of difference of squares. And I threw that plus in there because at the time we were factoring, we can't factor those. All right, so it was said to be prime because it was not a difference of squares, it was addition of squares. Well, that's not true anymore, okay? We set these equal to 0 and solve them. So from now on, like I said, everything that you got is not going to be prime. Everything now is factorable or solvable one way or the other, and we were going to learn other ways. But right now, we can solve these. Okay, so you just set that equal to 0, which means you move the 25 over. Okay, so now you have x squared equals negative 25. Well, to undo squares, you take the square root of both sides. So square root of x squared leaves just x, because that 2 right here, the understood 2, and this square root symbol, the square root symbol and this 2, they undo each other. Okay, so then that leaves you with negative square root of negative 25. All right, so when we did that before, that was a no-no, but now we can do this. That negative underneath the radical comes out as I, and then you end up having the square root of 25, which is 5, plus or minus. So this answer ends up being plus or minus 5i. So you're going to be simplifying using these complex numbers. Okay, so you'll be able to do plenty of these problems. Same thing would happen if you had x squared, say, plus 16. Okay, you would just set that equal to 0. Move the 16 over. Take the square roots of both sides. Okay, and then that leaves you with just x equals square root of negative 16. Well, we now know that that's going to be an I. So then you have square root of 16, which makes 4I plus or minus. Okay? So practicing with these things will help you a whole lot. Just got to remember, squaring and square roots undo each other, just like cubing and taking the cube root undo each other. Raising to the fourth power and taking the fourth root undo each other. So you'll use those back and forth a lot. All right, so properties you should be familiar with. Now I'm going to tell you, instead of the normal properties with regular real numbers, you're going to be mostly using and identifying properties with the non-reals. Okay, so you need to get real familiar with these crazy looking things, because that's what they're going to use on you. So a plus bi plus a negative a plus bi. So that would really look like, in real numbers, 3 plus a negative 3 in real numbers. That's the additive inverse. So try to think of this in reference to what we did with real numbers. All right, 3 minus 4i times 1 plus 0i. Well, 0 anything leaves just 1. So it's really 3 minus 4i times 1. Times 1 is the multiplicative identity. It's like 3 times 1 with real numbers, okay? If 5 plus 3i is equal to x plus 2 and x plus 2 is equal to y, then we could say 5 plus 3i equals y. That was the transitive property. 2 times the quantity of negative 4i plus 2. If you end up getting negative 8i plus 4, you distributed. And then 2 plus I plus 0 is just 2 plus I. Well, all you did is add 0. That's just the same as if you added 3 plus 0. Additive identity. 2i plus 4 plus 7i equals 4 plus 2i plus 7i. Notice the order changed. Changed order. It's always commutative, no matter which way we're using. Properties of real numbers or properties of non-real. And then the last one, 8i plus 3 in a parentheses plus 13i is equal to 8i plus, and then parentheses 3 plus 13i. It went 8i, 3, 13i, 8i, 3, 13i. No order change, just grouping. Grouping. So that's associative. Who was associated? It's kind of like the Mickey, Minnie, and Donald property. Okay? Y'all remember that with the real numbers. Same thing happens with non-reals. It's associative property. Alright, so that is all the notes on this section. They're very, very easy. You can use your calculator to do all of this stuff. Type in all this stuff just like you see it. All this just like you see it. Your calculator, if it's in the right mode, will do all of this. The only thing it won't tell you is what the conjugate of this is, and you'll just have to know. But if you type this in, you'll get a scientific number. Just cut it off. You'll get the part that you need. And this homework is due the next class. So if you have any questions, give me a call, come to the office. Send me an email. But let me know if you have any problems. This is really, really, really easy. I think you'll like this section a lot better than some of the other ones. But we will see you in class.